Hello students, I am Dr. Rajaram Dhok from Savitribai Phule Pune University affiliated Agricultural Development Trust Shardabai Pawar Mahila College Sharda Nagar Baramati. Let's start. So in the second lecture of Werner's theory, we studied about the verification of postulates of Werner's theory by using certain examples. So mainly here we take the example of cobalt chloride and ammonia. In the first lecture of Werner theory, we studied the different postulates of Werner theory, and according to that postulates, there is primary valency, secondary valency. Both primary and secondary valency should be satisfied. So we can see that verification by using examples. So Werner have taken the one important example, cobalt chloride and ammonia. So we take first example, cobalt chloride, and in that cobalt chloride 6NH3 is added. Then there is formation of the complex, and according to the coordination theory there is formation of CONH3 6 3 plus and 3 Cl minus ions are formed. Now if we see these examples, then CONH3 6 3 plus and 3 Cl, it satisfies both primary and secondary valency. Means cobalt has +3 charge, +3 oxidation number. To balance that +3 oxidation number, there is 3 Cl minus ions are attached. Cobalt has coordination number 6. To balance that 6 coordination number, 6 NH3 ligands are attached. And so this COCl3 and 6NH3 satisfies both primary and secondary valency and forms CONH3 6Cl3 complex. And so this is the Werner's coordination complex. If we see this Werner's coordination complex, then in that Werner coordination complex, total number of chloride ions precipitated by silver nitrate is 3, because when we add in this complex compound silver nitrate and test for the how many chlorine ions present, then there is 3 Cl ions, and total number of ions which is present in this, that is shown by the conductance, is 4. So here CONH3 3 plus is one of the ion, and that is the complex ion, and 3 Cl minus ions are present. So total 4 ions are present. Now we take the one other examples, that COCl3 is added by 5NH3. Then how that complex is formed, and it satisfies both primary and secondary valencies of coordinate Werner's theory. So when COCl3 is added by 5NH3, then there is formation of the product CONH3 5Cl bracket raised to 2 plus, and 2 Cl minus ions are outside the square bracket. So here cobalt has +3 oxidation number. They are attached by 5 Cl NH3 and 1 Cl. So coordination number is 6, that is satisfied by 5 NH3 and 1 Cl. Now here oxidation number is balanced by this 2 Cl which is outside the bracket and 1 Cl which is inside the bracket. Now this 1 Cl which is inside the bracket, how we can show this? And for that purpose we see this structure. Now you see here this first structure, this CO is attached, and that CO is attached by 6NH3. So for the first example, this is the structure that CO is attached by 6NH3 and 3Cl, which is outside the square bracket, that is in the second coordination pair. In the second coordination pair. So this is the structure 1 and this is for the first example. In this, CO is attached with 6NH3. It satisfies coordination number, and so that is called as first coordination pair. Then Cl is attached in the second coordination pair and it is indirectly attached with the metal. Now again, we see this table. Second example, COCl3 5NH3. It gives CONH3 5Cl. Here, this figure 1.2 or structure 2 is shown. Here CO is attached by 1, 2, 3, 4, 5 ammonia and 1 Cl. And 2 Cl is outside the square bracket, or 2 Cl is in the second coordination pair. Now you see here, this cobalt satisfies its secondary valency and primary valency and also secondary valency. So primary valency contains 5NH3 and 1 Cl, and primary valency is satisfied by Cl. Out of that, 2 Cl is in the second coordination pair and 1 Cl is in the first coordination pair. Now we take the next example. In that example, here cobalt is attached with 4NH3 and 2 Cl in the first coordination pair, and in the second coordination pair 1 Cl is present. So in this example, here CONH3 4 Cl2 Cl. This is example. In this example, 2 Cl are present in the square bracket or in the complex ion, and 1 Cl is present outside the square bracket as a primary valency. So here both secondary valency and primary valency are balanced. So how it is balanced? We see primary valency, secondary valency is balanced by 4NH3 and 2 Cl. Primary valency is balanced by Cl. Out of that, 1 Cl is outside the square bracket and 2 Cl is in the first coordination pair. So this 2 Cl satisfies both primary valency as well as secondary valencies. Now, next example, CONH3 3Cl3. In the CONH3 3Cl3, here we can see that here both primary and secondary valency have balance. So you see here in this example, CO is at the center, 3NH3 is present at the 3 positions, then remaining 3 Cl is also present at 3 positions. So all the 6 positions of secondary valency is balanced by NH3 and Cl. Now primary valency means oxidation number of cobalt, that is also balanced by this 3 Cl because Cl is negative charge. So here both primary valency and secondary valency are present in the first coordination pair and nothing is present in the second coordination pair.